The stream is hopefully working. Hi everyone, Microbehunter here. Welcome to another Saturday live stream. You might be wondering a little bit what I got here on my desk. Today I want to try to make a few microscope slides for sand. So what I've got here are some spacer rings here. I've got already some not so nice looking slides prepared here, and I would like to experiment today a little bit with those. First trials do not always look very nice, but in any case I would like to prepare a couple of slides here. I do have a few interesting sand samples with me, and we'll of course also put them under the microscope. Now if you're new to the stream, of course a big welcome. This is amateur hobby microscopy stream, and today, because I'll be looking at sand, I'm going to be primarily focusing on stereo microscopy here. I see that a lot of people are already starting to write something in the chat here. Hello all around the world. Of course, usually the first couple of minutes I read the chat a little bit to say greeting all around the world, because it does take a few minutes for people to join in. So there's a hello from Northern Germany, from Vietnam, of course, and Snoopy is saying hello from Linz in Austria, I suppose. And I would like to now know a little bit more about you. Are you maybe one of my students? I wonder, I don't know, because I myself am also in Austria, in the area of Linz. So hello from Mexico, okay, from the New Jersey, United States. The sound is okay, thank you. That is important, because some time ago I was actually broadcasting and the sound was a little bit distorted. Where did you get the sand from? I will talk about that. I have them some of my students brought them along from holiday trips, but I do want to say a little warning here. You got to check the legality, because it's not allowed to take along sand samples from every country, so be careful here a little bit. But in any case, I've never looked at those sand samples under the microscope yet, and this is actually one of the reasons why I would like to prepare those slides. Okay, one of my students has found me. I was already wondering. Okay, so a little bit some background information here. I've got here, and I'm just going to show this to you. Here, actually in my cellar I have even more. I've got a lot of sand. Okay, I have to shift this around here a little bit. A lot of sand samples here. I labeled the jar itself, and you can see that the paint came off. Luckily I always included also a little piece of paper with a description. So this one over here, for example, is from the Kalahari Desert, which was a student took along. This one here is from the Netherlands. Okay, this one over here from Crete, somebody took along. Cape Town, I visited South Africa several years ago. I took something from Cape Town. Over here, this one over here, from Ecuador, South America. Okay, I've got another sand sample over here. I don't even know. See, there's no label here. In any case, you get the idea. This one over here is Crescent City. This is California. Okay. So you see, I've got a few sand samples here from all over the place. The one that I've got over here, this is for tourists, which was sold. And those sand samples can of course be directly put under the microscope. I'm going to show this to you right now first, and then I would like to experiment a little bit, making some of those slides. So this is you can see on top here my stereo microscope. And see even a little plant, the leaf in here, and then of course I'm able to zoom in. And if we're lucky, we're able to find a couple of shells of some microscopic seashells or so. Did not find so many here in those sand samples, but I think you get the point. And I would like to actually prepare them in such a way that we're able to look at them properly. Okay, so that's a lot of countries. Well, I do have more in the cellar, but again, I stopped collecting them over 20 years ago, because all of a sudden I figured out that some countries, they don't like it if you take along sand samples. For example, I do not have any sand from Italy, because there, or in some regions of Italy at least, it's strictly prohibited to collect sand from. So that's why I highly encourage you to honor the local legislations and the laws here. Okay, so and this is yeah. So just let's go. Yeah, if you have any questions about anything microscopy related, then please make an @ Oliver or @Microbehunter, so that I can skip directly to that comment, and then I know that this is actually for me. As a couple of other organizational things, that a few weeks ago, all of a sudden the live stream was interrupted. I don't know why, and simply after a few minutes it simply shut off, and I had to then completely create a new live stream, okay, using a different link. So should this happen again today, then yeah, you gotta be patient a couple of minutes, and I'll try to pick it up again. And last week, because I was not around, I pre-recorded a live stream as well. So this was called a YouTube premiere. So yeah, so what I got here is the following, where I have to switch always back again to the desk view again, okay? You might have already seen this before here. This one was actually one of my first microscope slides, and this is using a so-called a concave slide. So these slides basically have concave indentations, and what I've done is I put a sand sample in here, cover glass on top, and using blue nail polish, I use the blue color so it's easier to see. I put a cover glass on top, and this basically means there is no water, no liquid in here, and the sand is surrounded by air, and this way you can shake it around a little bit, and this way you're able to look at the sand grains always in a different way. I've also made the following before. You might have also seen this. Here I applied a little bit of glue on the slide, and then I sprinkled the sand on top, and now the glue kind of holds the sand grains in place. This, however, does have a little disadvantage, and the disadvantage is that you're also able to see the glue. Okay, so and for this reason I have 3D printed some spacer rings today. Okay, a little bit in black and also in white. That's the reason why I'm now experimenting a little bit by making those spacer rings here, so that I'm also able to make so-called dry mounted microscope slides. That's essentially what I'm making here. I'm not using a mounting medium, but they're dry mounted. You just see that my hands are all the way. Just a second. I've got this new camera here, and but with the push of a button I'm able to turn it up, turn it correctly now. So that's basically also a little bit easier for me. Okay. So yeah, so I have a look here again. No comments. Yeah, I hope that I do not miss any comments. Sometimes there's so many comments that I'm not able to read all of them. Hello from Romania. Okay, hello from Poland. Yeah, hello from the middle of the Atlantic Ocean. How is that possible? From New Zealand. Yeah, that's yeah. So yeah, so let's do the following, just so that you see a little bit how this actually looks like. The stereoscope view. Here we are with this slide here, and you see that the sand grains. Okay, I have to always. Yeah. And occasionally, you are able to see find something interesting as well. There are different types of sand around, of course. Quartz sand, also sand containing lots of calcium carbonate from seashells, so it depends quite a bit. But again, today's live stream is mostly focused on experimenting, making those dry mounted microscope slides. Mitch Wasserman is asking me, Oliver, after viewing pond organisms, I put the slides and cover slips in a 50-50 solution of 70% alcohol and water for a few days. Is it safe to assume that the organisms are dead after being in that solution? Yes, you can be quite sure that many of them are dead. 70% alcohol is the standard solution of concentration of alcohol that we use in the microbiology lab for disinfecting surfaces. As a matter of fact, a higher and a lower concentration of alcohol reduces the effect of disinfection. So interesting, even if you go up with the concentration of alcohol, the effect is not quite as high. The reason is because 70% alcohol is just the right alcohol concentration to dissolve the cell membranes. However, yeah, So basically, however, I have to be honest with you, I am not even doing that. I'm not even disinfecting my slides, because if you have pond water organisms and if you're not enriching those organisms and if the bacterial count is low because it's still fresh pond water, then I'm not worried so much, because this is a pond in any case where I'm swimming. I'd be only worried if the material is decomposing and if the bacterial count goes up quite a bit. Okay. Yeah, so that is the one thing. So let's show you before we start making some slides here. That is the other one over here, where I basically glued it directly on the slide. And you can see that because the glue that I used kind of surrounds the sand grains, the individual sand grains are not quite as visible. Okay, and this is not so nice, I think, and therefore I decided that, yeah, having the sand grains in the more natural state looks actually quite nice. Okay, so how are we gonna do that? Okay, so how are we gonna do that? It's gonna be a little bit experimental, and those of you who have joined in the live stream in the past already know that I'm not giving perfect demonstrations, but it should be rather a little bit of a motivation of trying the things yourself. See, I have to switch around the camera every time again. And I would like to also show you how to use a so-called slide ringing table. Okay, and a slide ringing table allows you to make yeah, those so-called spacer rings here. And I'm using nail polish. Why am I using nail polish? Because it dries quickly. But then I found out that essentially it's not thick enough. Okay, and for this reason I 3D printed some of those spacer rings here. And yeah, I would like to try that out. And I'm going to show you, before I do that, I'm going to show you two possibilities here. The professional looking one and the improvised one. This is a so-called slide ring. You know what? I'm going to just show you the whole device by holding it up. Okay. This is a so-called slide ringing table. Okay. This is how it looks like. This bottom part is able to spin. Okay. This is a rest for your hand so that you're able to hold a brush properly. Yeah. So this is basically one thing. Polarized light. I can use polarized light. I need the filter, which is over there in my drawer. Okay, so I'll try this later. And what you do is the following. You put a slide in here, and then you're able to hold a brush here, and you're able to, as the slide spins, you're able to make those rings here. Okay, I'm going to demonstrate this to you. This is quite a nice little thing here. However, there are, of course, also homemade solutions. Or look what I found here. I also have to show it to you. Yeah, look, it's made of, I don't know, wood. It also has this spinning platform, and this is used by people who who make pottery with clay. Because they're spinning this and they're making little, I don't know, dishes and cups and vases. Huh? And I bought this here actually to for demonstration purposes. So I can put a microscope on here, I can rotate it. Excuse me, I can show all of the different sides. But of course, if you have something like this, excuse me, you might also yeah, might think of taping maybe a slide on here and then spinning it, and then you're also able to do that. Okay, I'm not going to be using this here, but I just wanted to show it as a kind of a proof of concept. Okay, so this is kind of I bought this over Amazon. Yeah, so this is kind of the another possibility, but I did not try it yet. But I see no reason why it shouldn't work. Okay, so that's kind of the simply a thing I just wanted to show you. But I've seen several people who are actually making their own things, things here. Okay, please, would you tell us how thick your 3D printed distance rings are, and working with ringing table and reinforcing rings, Verstärkungsringe für Aktenlochen. So what I made is those two. I got actually two different thicknesses here, arbitrary thicknesses, 0.5 millimeter and 1 millimeter. Okay, and I will tell you what the problem is. The problem was with some of those. The problem was that while the bottom surface is very smooth, the top surface wasn't very smooth. Maybe you can see it over here, right? Yeah. So maybe my 3D printer is not properly adjusted. So what I did is I took a sharp knife and I also kind of scratched off the surface. But in Cura, that's the 3D printing program, there is also an option. You have to make a tick to kind of iron it out. So basically what it does, it kind of moves over it again to smooth it out. It's only a check mark that you have to set. and this kind of makes it smoother, but otherwise you have to kind of use a sharp knife to scratch off the surface. Okay. So there's a question, what are you doing tonight? And yeah, today I'm trying to make slides with spacer rings to observe sand samples. So, and what I'm going to be doing, just as a demonstration purposes, I'm going to now use nail polish, and I'm going to use the slide ringing table, okay, to make some spacer rings. But because it takes some time to dry, I'm just going to use the other one, yeah, to show you. So I'm going to clip this one on here. I'm going to clip this one on here, okay. You are able to rotate this now. I take some nail polish. I'm using blue because blue is a nice color and it's easy to see. The contrast is good, and make sure that it is sufficiently liquid. If not, you have to add a couple of drops of acetone. Okay, and look, this is what it's not going to look very nice. Okay, it's going to be very thick, but people who have a lot of experience with this are able to actually yeah, get quite nice results. Yeah, so the first layer is completed. So what I do is I allow it to dry a little bit. I think maybe I'm going to try the other bottle. Maybe this one over here is a little bit more liquid. I don't know. And I'm a little bit off center as well. So let's see if this works better. Okay. And I'm going to apply the second layer now. Okay. I give it again a couple of minutes drying time. Okay. Third layer. Yeah. And so on, okay? And that's basically what I've done several times. However, I'm not able to, yeah, maybe a third of a millimeter. So those spacer rings really allow me to go much thicker. It really depends what you want. The difficulty with those spacer rings, however, is gluing them on the slide, okay? Because it doesn't look so, yeah, it looks a little bit ugly because of the glue or the nail polish, yeah, being kind of, yeah, splattered around, yeah. So this is basically how it works. Yeah, you simply keep on adding layer and layer and layer. However, what I want to do now is the following. I'm going to leave it like that, and I'm going to try to actually use this now, not as the spacer itself, but I would like to use this now as the glue to add a spacer ring. Okay. Let's use the rough surface to the bottom. Okay, I think that's the rough surface. That's correct. The smooth one is on top. Okay, and here we go. I think this looks actually much nicer than the other ones that I made. And then you give it an hour or so for drying. Yeah. Maybe even less. Yeah. But I think this one is okay. Again, the reason why I'm using the blue nail polishes is because it's easier to see, but it's, as you know, it's a question of taste really. So if you want to use clear nail polish because you don't like to see the ring, then it's of course, yeah, whatever you can do, okay? So I'm going to leave it on here right now. The reason is because I'll be adding now later on another layer around it so that I'm able to glue on the cover glass. And what I've got here is, I think it does not appear to be in focus. Just a second. By pressing this here. Yeah, this is autofocus. Yeah, this is the camera that I'm using now is different than the one before, because this one actually is for taking pictures of documents. Yeah, paper documents. Yeah. So here I've got my round cover glasses this time. Okay, and I would like to glue some round cover glasses here on top. Okay, but as I'm waiting a few minutes for it to dry, I'm going to go back to the comments section and I'm going to read them a little bit. Can you use polarized light? Yes. Would you tell us how thick the sweep? Yeah, 0.5 millimeter or a millimeter. Why exactly that thickness? Kind of arbitrary. Okay. Yeah. Yeah. What's your name? Well, I'm Oliver, and I'm 52. Okay. Would the thickness of the ring allow short working distance objective to focus? Ah, okay, that's a good one. Be careful. If you have maybe the 4 times objective might be fine, but because it's pretty thick, high magnification is not going to work, and it is not meant to be used with high magnification. because if you want to get the resolution of a high magnification power, then you actually also need to have a proper mounting medium with a proper refractive index, and we're just using air as a mounting medium. And actually the real reason of why I'm making those slides is because I want to use epi illumination. That means light coming from the top using a stereo microscope. So for the high power microscope objectives that have a small working distance, these slides are not suitable. And even if the distance would work, you wouldn't see a lot anyway. Okay, so it is actually designed to be used for stereo microscopes. If you want to, what you can do is of course you can use the low power 4x objective and then use a flashlight from the top. I also made some videos about that, and then this also works. Okay. Yeah, the microscopy shirt. Some time ago I said I want to brand the channel a little bit more, so I made myself a shirt, and then discovered that the logo is actually too big and not quite the correct size. But yeah, can I cultivate specimens by adding some soil to clear water in darkness, or should I add nutrients too? Can I cultivate specimens by adding some soil to clear water in darkness? You want to grow some microorganisms, but you do not want photosynthesis to happen. Yes, the thing is the following. It depends on the microorganisms, of course. But if you add nutrients, like a little bit of some carbohydrates, cornflakes, a small piece, this is called an enrichment culture, or a crushed wheat grain, for example. It's called an enrichment culture, and you have to be a little bit careful, because as soon as you add nutrients, the number of bacteria can explode very quickly. And if you have a lot of bacteria in your sample, then this pushes down the oxygen level, because the bacteria respire and use up all of the oxygen. The whole thing starts to become bad and smelly as it decomposes. So you have to make sure that there's always enough oxygen present, and you have to make sure that the other larger microorganisms like the ciliates, amoeba, for example, all the protists, that they are able to grow well because they feed on the bacteria. Right? So it's a delicate balance. Do not overfeed. Okay? Do not overfeed. Yeah, somebody's actually answering this here. Okay, about the working distance. Okay. Yeah, so maybe this is fine now. I don't know. Okay, so let's push this a little bit. Yeah, it seems to be quite solidly connected here. I think that's gonna work. So I'm going to take out now, yeah, a sand sample. I don't know which one. The one from the Kalahari, is actually quite nice. Can you do chromatography through a microscope? Well, chromatography, like paper chromatography, requires a separation of substances and then observing it under the microscope. Never tried that, but simple chromatography should be possible, especially using the stereo microscope. Maybe you're able to separate some of the colors of a pen, for example, or of other pigments. You don't see that, what I'm doing right now. I'm basically, opening this one up here, and this is this was a present over 20 years ago from someone. And it's a very nice sand, a very nice red sand. And what I would like to do now is I would like to take out a little sand sample and put it in here, and then cover glass goes on top. Okay. Honestly, I've not tried this before. Okay, so this is a first thing. Sometimes I like the, how do you say, the experimentation. Unfortunately, I don't have a spatula, so I'm just going to use those tweezers here. Okay, so let's add a little bit of this sand here. So, and of course the thickness of the spacer ring depends to a large extent, of course, on the size of the sand grains. Okay, so maybe it wants a little bit more. I don't have to fill it up completely because I do want the sand grains to move a little bit as well. Okay, let's spread it a little bit. Okay, maybe tiny more amount more. I think that's gonna be fine. Okay, so and now the tricky part. Okay, the tricky part is now the following. I have to apply again a little bit of I don't know. Let's tap it a little bit, maybe to spread the. So I have to now apply again a little bit of this nail polish or glue or whatever. Another thing I didn't know, which I did not try, and this might also work, is you might try super glue, cyanoacrylate glue, because it's very viscous. So this would allow me actually to place the cover glass first, and then a little bit of the super glue, and then the capillary activity of is going to pull the super glue around, and then it's going to flow around it. That would be a possibility. However, I don't have any super glue with me, so I'm just going to try it again, the traditional nail polish method. Okay, so here we go. This is a round cover glass, 18 millimeters. It should fit exactly over on top here. I always first dry wipe it. Okay, I'm going to dry wipe it first. So there's a question, will there be a replay of this? I'm studying for test. Yes, the video, all of those live videos will all automatically be available online on YouTube. All you have to do is you have to click on the menu live streams, and then you're able to see all of those also from the past. Okay, so everything, nothing is going to be lost. So if you are busy doing something else, please do so. Somebody is studying for a test. Of course, test has a priority. I'm a teacher myself. So let's have a little look if this actually works out. I hope that the nail polish has dried sufficiently well so that the ring is not moving. So let's apply a little bit here. It seems to be fine. You know what? I'm going to apply a second layer. Okay. You know what? Maybe a third layer. One shouldn't wait too long, because after all, the nail polish is drying rapidly. Yep, let's give it a try. And 1, 2, here we go. And let's place it over it carefully. Press down a little bit. And even if it doesn't close off everywhere, I can always add another layer afterwards, and then the nail polish is going to start to flow inwards. See? It was lifted off a little bit. One has to be careful. Yeah, it has to make sure that there's not too much sand present. Okay, maybe that now it works, I hope. Okay, tap, tap, tap. Okay, and I hope that this is stable enough. I have no idea. Okay, that's the first first slide. So, you know what? Let's put it under the microscope, okay? And let's see how this actually looks like. Yeah, so this is a little bit, I'm still a little bit worried. What I have also made in the past is, and I don't, again, all these things come into my mind as I'm talking. You can also try to paper cover them. So what you do is you you buy yourself a puncher, and you punch out round circles from a piece of paper, and then you can actually glue it over, and then you have a nice window. This essentially not only stabilizes the cover glass from the side, but also kind of protects the slide from cracking. Okay, so that is basically, yeah. The question is the Kalahari Desert sand red because of the high levels of iron oxide? Possibly. I don't know, but that's something that could be easily researched, I think. Okay, you see that the sand is moving around. So let's have a look. And I need to switch over to the stereoscope. Here we go. Where is it? Where is it? Here we go. Okay, and let's start to zoom out a little bit here. This is how it looks like. Focus in a little bit, yeah, and yeah, microscope not properly adjusted. That's why I have to refocus. And this is basically the sand grains. Okay, you see some of the sand grains managed to actually go now into the nail polish here, and they might prevent a good contact. Okay, so that is so you see that the This can also be used as quality control. So what I'm going to do is I'm just going to leave it as it is now until the nail polish has dried. And then I'm going to, maybe tomorrow or so, apply another ring on the outside. So basically what's going to happen is I'm just going to use my tweezers here as a pointer. What's going to happen if I apply another ring of nail polish on the outside is that it's going to seal it from the top here all the way down to the microscope slide. And this adds an additional stability to this. So you know what? Yeah. Why not try the other microscope now? Okay, so here we go. I need to switch it on. Yeah, so that's the 4x objective. The image is not quite centered. So let's do the following. So let's have a look. So this is light coming from the bottom. Okay, and you see this is doesn't look quite as nice. Okay, and you also do not see the red color anymore. And yeah, so this is basically the reason why those slides are actually suitable for epi illumination. You see, unfortunately, every now and then you see the pink picture flashing. There's some problem with my HDMI to USB converter, I think. Okay, yeah. So sometimes, every time when you see this noise and this flash, that's unfortunately, I don't know why it's doing that. So that's a 4x objective. So I'm going up with the magnification now. Okay, so now we're able to see a little bit the color, right? But again, it doesn't look quite as I think it doesn't look quite as good. Yeah, but it depends on what you want to look at, and the magnification, however, is much higher. That's a 10x. This is now the 20x objective, and you see it still works. Okay, and I'm going to put in now the condenser as well. Depth of field is very narrow, and then you're also able to see that not all parts of the sand grains are actually stained red. So especially if you look at it on the top left side, where's the arrow? Do I have an arrow over here? Yeah, this is something that I already noticed before, that there are apparently regions in the sand grain, yeah, that actually make it appear red. So maybe these are patches of iron oxide, rust, I would guess. Yeah. And I can imagine that maybe if when light goes through it and is reflected, it makes the whole sand grain kind of appear more red. So this sand should look very nice under polarized light. Can you use dark field? Okay, this is something that I can do using the low power 4x. I only have dark field with the low power. This is now. No, I have to use like this. It's not centered. It's not quite centered, but that would be dark field. Okay. It's a little bit. Yeah, it's not quite centered. The image. Okay. Yeah, in the software. That would be dark field. Yeah. So this is. I only have dark field using the 4x microscope objective. For those of you a little bit more into the technology here, why only for that? Because this is actually not a dark field patch stop, but it's actually the annulus ring for phase contrast. Yeah, for the 40x, but it works also for dark field. So that's kind of a little bit the technical background here. Okay, so but as I said before, I probably like the stereo microscope view better. And you know what? Why do we not try to make another slide? Maybe the more slides that we make, the more the better I become here. We can actually use maybe some of the slides that I already made before. Okay, so I'm going to go back to the desktop view. Again, it takes me a little bit of time here, and let's try this here. Okay, so I'm going to put it in here again, and here again. So let's get it centered again a little bit. It's not fully centered. It doesn't matter. Let's try a different sand. The one from Cape Town. How is that? Cape Town. From the year 2000. It's Cape Town, South Africa. Oh, hear that? Horrible sound. Sand grains scratching. Okay. Yeah. You always want to not contaminate, cross-contaminate. So I'm going to wipe off the tweezers here. And let's use a little bit of this here again, and carefully fill it in. You're not able to see this. So here we go. Of course, this principle can also be used for micro aquariums. In other words, if you have slightly larger organisms like water fleas, for example, water crustaceans and so on, and you do not want to crush them with a cover glass, then you might also consider these spacer rings. In the past, what do you mean in the past? I mean, a couple of years ago, before I had a 3D printer, I tried to use cardboard rings. I punched them out using a hole puncher, a larger one with a hammer, and then I kind of punched them out. But I found that the cardboard had significant disadvantages, and the disadvantage was that it was absorbing all of the glue and the nail polish. So it soaked up all of the nail polish, and it did not stick to the slide, therefore, because there was simply not enough nail polish between the cardboard and the slide. So it didn't work. So, and this reason why those plastic 3D printed rings are actually more suitable. What you might also want to try if you don't have a 3D printer, most of you don't have one, is to actually use old credit cards, or cards, those cards that they have for voucher cards, those plastic cards. They might also work. Okay, so this is also a possibility. So just getting it cut out into a nice round shape might be the challenge, though. So let's give it another try here. Okay, if this works, I don't know. Maybe I'm going to use a little bit more of the, and yeah, not so good yet. Okay, this is not very liquid. I just realized. So maybe the other one is a little bit better. Otherwise, I'd have to add a little bit more acetone or nail polish remover. This one is better. Okay, and another layer. And another layer. Honestly, this is highly experimental. I've never seen anywhere on YouTube anyone trying something similar here. So if you have any advice to share or so, please, there is a comments section, or maybe you have links to other YouTubers who have been doing something similar. Okay, so let's share the knowledge a little bit. That's kind of my suggestion. Ooh, now this is a lot. This is a lot. Okay. So let's try this here. If this actually works very quickly before it dries, it's a little bit difficult to see if it is properly centered or not. Yep. Yeah, I think this actually made pretty good contact. Yeah. Another thing that you should just be aware every time when you use nail polish is that it starts to shrink quite a bit when it dries. So this basically means that it might definitely be necessary to add more nail polish maybe later on. Yeah? So nail polish really shrinks quite a bit. So I'm just going to leave it as that, and I shouldn't forget on how to have to add a label later on. And let's have a look at this. Okay, so there are a couple of questions here. Can you use dark? Yes. Are there any other choices besides nail polish? Yeah, sure. You know what this is here? This clear. Are you able to see this here? This is. You're gonna laugh now. This one here. Yeah, that's the Elmer's clear glue, which I'm also using as a mounting medium. However, I think it's very thick, so you should be diluted down. So glue. Yeah. So I'm using just nail polish because it dries very quickly. That's pretty much the only reason, and because it sticks quite well to the glass. in my view. But it's essentially, this is something that I've simply experimented with. Yeah, because you're asking, as it still dries. Look, when I bought this slide ringing table, it came along with a couple of paints here. I just want to show them to you. I bought this, the company is called Brunel Microscopes in the United Kingdom. I'm just going to, yeah. And it came along with different paints that can be used. But I'm just using nail polish because that's what I'm used to. Yeah? So this is basically, also a possibility here. So now let's have a look under the microscope. Or punch rings out of plastic milk containers, sure. Or plastic packaging material. I don't know if I have something. Here it is. Look, this is just the travel adapters for electricity. But you see, there's this plastic. Okay. So that might be actually an option as well. So let's now really look at the stereo microscope. So that's still the Kalahari, and now this is the other one over here. Here it is, that's the sand from Cape Town. Okay. Yeah, so I'm just realizing one thing, you know what? Why not try a darker background here? Okay, looks a little bit better. Okay, better contrast. I mean, it looks pretty white. It looks maybe a lot of quartz. Yeah. Sometimes it's yeah. What is this here? I don't know. So go up a little bit with the light. No, that's the other one here. Yeah. You get the idea. Okay. Yeah. So so that's basically the second example. You see, the further you zoom in, the darker it becomes, but I think I did now, yeah, it does do a little bit of auto exposure as well. If you watched one of my previous videos, I did now include also a Barlow lens beneath here. The Barlow lens reduces the magnification as well, because otherwise it would have been a little bit too big. Yeah? So, but you know what? Let's have a look at this one under the other microscope. Okay. Where do we have the other one here? That's still a dark field. Let's do it like this. Again, let's flip out the condenser, and this is how it looks like. Yeah. Under 4 times magnification. Yeah. Could you try thin 2 parts epoxy resin or heat the resin to make it runny to embed the sand grains? I see no reason why this should not work. And I will tell you why. Epoxy resin probably is indeed, and it's also something that I've considered before, why I considered this myself. Do not, if you want to try this, I have not tried epoxy resin yet. But when you want to do that, then do not use epoxy glue, but there are those very liquid epoxy resins that people use to make tables, furniture, or put objects into this clear epoxy. There are many YouTube videos out there that demonstrate how to do that. I don't know how this technique is called, but essentially you can take pretty much any object that you want, I don't know, like this pen here, and put it into a box surrounded by epoxy, right? As a matter of fact, some months ago, you got to check this channel or the other one. I actually put some insects under the microscope, and those were gigantic beetles and insects that were actually preserved in this epoxy resin. And you basically just take it as it is, and then you basically put it directly under the microscope. So yes, I think this should be possible. I've not tried it yet, but that is indeed something that I've also been thinking about. But I don't have experience by actually making these epoxy objects. Yeah. Yeah. So there is this. There's some comments. Yeah. Could thin to power. Yes, we keep insects in A and B epoxy in a latex glove. Okay, yeah. So this is basically simply something that can also be tried. Yeah. I think not a problem for stereo microscopy. If you want to use it for compound microscopy, the refractive index of the epoxy might also have some kind of an impact. So, but you know what? Let's just go up a little bit here with the. Now this I turn on DIC, and you see immediately that, of course, the depth of field, yeah, is quite low. Yeah. Yeah. So essentially, those sand grains are quite large and quite thick, and therefore it's not possible to get them all into focus. Let me turn the arrow off again. Okay. So that's a little bit the thing here. Yeah, you know what? Now you know how to make those, one possible suggestion, how to make those slides. But let's have a look at the other sand samples directly under the stereo microscope, just because it's so fun. What time is it? 45 minutes already. Okay. Yeah, so yeah, let's have a look at some other sand grains here. Gotta clean up the mess here as well. So I'm going to move everything a little bit away here. Okay, and then let's have a look at the next one. And in this case, I'm not going to make a slide now, but I'm just going to take the container and directly put it under the microscope. Just so. The next one here is I don't know. I don't have to open it. Just a second. Let me quickly read it. I've put the. I also put a little sheet of paper in here with a description, date and everything. Does it say? Cannes. Southern France. Okay, year 2001. Yeah. So let's. I need to. Where's the stereoscope? Okay, so that is French sand. I'm just going to put it directly in here, and I have to, of course, zoom out, and I'm going to go up a little bit here, and. This is the French sand. Okay. See, it's not only sand. There are also some plant materials in here. Different. I'm not so totally happy with the image quality of this camera, and the reason is it's not so much the camera's fault, but I think that the intermediate optics of the camera are not quite as good. And the camera's small sensor also adds an additional level of magnification, right? I'm not post-processing these images here. I could actually add a little filter to increase the contrast. And as you see, it goes a little bit out of focus, and the reason is because the sand is not totally flat. Yeah. Yeah. So this is a little bit. Yeah. You might have noticed that over the last couple of weeks or so, I've always repeatedly used the stereo microscope. I'm doing this deliberately because I do want to also promote stereo microscopy a little bit, because I think it's also pretty cool. Huh? Could there be problems if you simply use 5 or more layers of nail polish instead of a spacer ring and let each layer dry thoroughly? It just takes time. I've tried that, and it actually works. Okay, I don't see a problem really. I mean, so yeah, here this is actually one. I think of 3 or 4 layers, and I've tried that. The only thing that's a little bit annoying is that if you apply layer after layer after layer, the ring might become thicker and thicker and thicker, and you make a small mistake, and then it doesn't look as nice anymore. It's cosmetics. I don't see a problem with that, but I kind of think it might be a little bit difficult to actually make it a full millimeter high. Yeah? So I would say as often you got to try it out. Okay, I've actually worked with multiple layers before, but not quite as high as the ones that I have here. Right? So this was a sand from Cannes, southern France. Okay, and let's always close it again. This one is quite interesting here as well. Where is this one from? Yeah, Crescent City. I think this is in California. Yeah. Somebody took, yeah, so. Is there something as a perfectly round shaped grain of sand? It's almost a philosophical question. What is a perfectly round shaped? How many atomic layers of atoms are you allowed to be off for it to be not considered perfectly round shaped? I think it's a question of statistics, maybe. Excuse me. Let me take this out again, the piece of paper. Okay. But of course, due to wave action and wind action and erosion, of course, for this reason, of course, sand grains, yeah, become smoother and smoother and smoother, and then yeah, you know, that's actually, I think that's actually a nice looking one. Many different, yeah. And you see how round they are. And by the way, this is a way how you can actually distinguish natural sand versus artificial sand. For example, crushed sand. I recently made a video where I put some sand under the microscope which is artificial, and this artificial sand was used to make, for example, sand sculptures. It has to be artificial sand because there are more edges in the sand grains, and this causes a tighter interlocking of the sand grains. And if you actually see round sand grains like this here, then you know that they've become round because of natural erosion processes, and yeah, therefore this is not crushed sand. Okay, so see, some of them are a little bit have corners, so I think this basically means tells you also something maybe about the age, how long the sand particles have been in nature, and maybe also something about the hardness. I mean, there are some folks who are actually polishing their own stones in a so-called in a rock tumbler, yeah, to get very nicely polished rocks. And here we see that many of them, yeah, look just like those tumble polished rocks here. Yeah. So I'm going again. Yeah. I don't have a stereo microscope, but I do love seeing sand under the stereo microscope. It looks pretty cool. I just want to show you something here. Just a second. I gotta reach down. I'm not gone, but I hope I'm able to find it. Here it is. Here it is. Here it is. So if you don't have a stereo microscope, but you want to get a stereo microscopic effect, and you don't want to spend so much money on a stereo microscope, I can recommend the following here. This one here was, I don't know, less than 10 euros. I think 7 euros even. It was ridiculously cheap. And this is a USB camera. Unfortunately, it doesn't work with, there is some issue. I've got it already a couple of years. Otherwise, I would have actually showed it to you. But essentially, there's a camera in front, and there's even an LED. And then what you do is you take the thing off, and then you kind of point to whatever you want, and you can actually get an image that looks exactly like the one that you have here, right? So this is a poor person's stereo microscope. It does not, of course, it does not give you the stereoscopic effect, okay? I think they're really fun to use, okay? I'm kind of surprised a little bit by the price difference that some of these things have. But this one really was extremely cheap. It was really less than 10 euros or dollars or something like that. So I just got the cheapest one I could find simply to try it out. So I recommend those things here if you want to have something fun to play around with, but do not want to spend too much money. Okay. So this is sand from California. Okay. And let's put the... I think it was a good idea that I put a piece of paper into each one of them, because this one is South America, Ecuador. Okay, you see the level of the sand is much higher, so I have to move it up here. Ah, look at this. This is also interesting. It looks very dusty, so this means that there must have been also some silt or some other things must have been mixed into the sand. So maybe I could improve the image a little bit by taking a small sample and giving it a little rinse to rinse away the smaller particles. That would be also quite, you don't actually see that from the outside. Yeah. So I think the sand here does need a little rinse. It can also be that, there maybe there's a little bit of clay also mixed in, and that's why it looks a little bit whitish. Yeah. So I've been told that meteorite grains can be found sometimes in the gutters of building roofs. You're talking about so-called micrometeorites. Yes, and I too have been experimenting around with those micrometeorites. I want to just say again, there are lots of resources online available, and you can look for micrometeorites using a magnet, because many of them are tiny spherical particles made of iron. However, apparently you cannot be 100% sure that they're actually from outer space, because there are many small spherical metallic particles which are man-made, made by humans as well. So if you really want to make sure that this is comes from outer space, cosmic dust as it's called, then you actually have to do further analysis, which is beyond what most people are able to do. Yeah? Microbehunter, if you would illuminate the sand specimens from the side by using a bright flashlight or other light source, would this cast shadows and then thank you for the comment. Look, I'm gonna try this again. You know what? I'm going to use the flat one. Okay, let's go again back to the Kalahari one. So basically the question is can I change the lighting technique? I'm now using here at the top, I need to sum up, this one here is an LED ring light. Okay. However, I have two more lamps available on the stereo microscope. There is a lamp over here, which is switched off, which is basically light from the side, which hopefully casts a shadow. And then there is also a lamp here, light from the bottom. Let's try those. Okay. So I'm going to switch off the ring light. Okay. I will turn on now the light from the top. Okay, it is not quite as strong as the ring light, and for this reason, okay, it might not be quite as bright. Okay, so, and this is the other one. Yeah. So that is essentially light coming now from the side, and now this is light coming from the top. It looks, indeed, does look more flat if it's evenly illuminated. Yeah. Yeah, it's a little bit dark because the LED is not quite as strong. Okay, but yes, there is a difference. Okay, so and now let's try it with light from, or maybe let me see if I'm able to turn it up a little bit. No, it's already at maximum. Okay, so and now with light from the bottom. Okay, this is how it looks like from the bottom now. And top and bottom. and ring light. You know, this is way too strong now. Right? So you see there are different ways of how you can actually try this out. And I think that indeed if you use a flashlight, a strong LED flashlight, and really go flat, then it might actually look even better, because indeed then it will cast more shadows. But I think it might also depend a little bit to the extent that those sand grains are able to also allow light to go through. Okay, so the magnet idea, yes. If you go, I like the magnet idea for looking for those micrometeorites. Just type in micrometeorite magnet, and you're going to find plenty of sources. However, as I said before, many of those round, microscopic, spherical micrometeorites might not be cosmic dust, but might be from Earth. Okay. Where is it better to search microbears? Near pond, in forest, or puddles in the city? I guess you're talking about you are talking about those water bears. Those water bears, or how do you say, moss piglets, if this is what you want. Yeah, what you do is those moss piglets, you need to find fresh moss. I've got not so fresh moss here, okay, which you've seen already before, and essentially if it's fresh, then chances are pretty good that you're going to find water bears in them. Okay, so so let's try another one. I don't know if you're interested. How much time? It's already 1 hour. Actually, I promised myself not to do these live streams all too long. I wanted to actually cut it off after 1 hour, but okay, well. So let's have a look what this is here. I think I already looked at that, or not. I don't remember. Let me see. No, this is one. This is the one that I already looked at. That's yeah, from Cannes, from southern France. And there is, where is this here? This here is from Crete. Ah, yeah. This is from Greece. Okay, let's do it like this. Crete is a, I've not been there personally before. Sand from Greece. Again, here this white thing, that's the paper with the label. It's also pretty colorful. Ah, people are waiting for the polarized light. Okay, yeah. So you know what? You have to give me then 10 seconds to quickly jump up and get the polarized light filter. Okay, and then let's try it out. It's just across the room. So, I am back here, okay, with some polarized light filters, which I'm going to also explain to you. So let's quickly have a look here. So that is the sand from Crete, from Greece, an island from Greece. Again, these were all presents, okay. But then again, if you joined in, please be careful when you collect sand. Okay, it's not always legal in every country. And you don't want to get in trouble, but at least I can say that this one here is for educational use, and this one here is from the Netherlands. Okay, this is from the Netherlands, Dutch sand. Let's have a look. I mean, there are. Is this natural sand or is this? It looks a little bit more. Yeah, like it's a little bit more, has slightly more corners here. No, but I remember this beach was a natural beach here as well. Okay, yeah. So this is a this is a beach in Noordwijkerhout. It's difficult for me to pronounce. Noordwijkerhout, one of the longest names. This is the beach in the Netherlands, which I had 20 years ago. I visited this place because I was on a workshop. Yeah, yeah. So. This, yeah, and I got a few more sand samples, but I think right now we are interested in the polarized light. No promises that this is going to look good, okay? Just want to illustrate the principle here, okay? So, and yeah, mostly I've been doing microscopy of water microbes and biological things, and why not also look at other things every now and then. Yeah, even at the danger of repeating myself, but maybe some of you are new and have not seen this yet. They are cheap, those 3D glasses. They use polarized filters, but I do not recommend them. I do not recommend them because these are circular polarizing filters, and then you need the correct orientation. Some of them don't work properly because you have to have two matching filters, and not only the degrees are important, but also the orientation. So while this is possible, yeah, there are easier ways, let's put it this way. What I recommend is that you buy yourself here so-called linear polarizing filters. I got this from Amazon. There is a protective film on here which I did not remove yet. You can cut them into shape if you want to. Yeah, and essentially they're quite cheap, very versatile, and also very thin. So that means basically you can actually put them also over a microscope slide, and if you, for example, want to observe crystals. And these here I bought long time ago, and I removed these were for camera filters, linear polarizing filters. Now they still sell polarizing filters for cameras, however there are circular polarizing filters just like those here. Yeah? And I think again linear polarizing filters are much easier because essentially what you do is you put one here on the bottom, you put one on the top, you rotate it, and you see that there is this crossed position where you're not able to see anything, right? So, and what I'm going to do now is I'm going to try to see how this looks like, and what I do is you of course want to have the stereoscope view again. Now I need light from the bottom, okay? That is important now. This is basically light from the bottom, okay? Let's do it like this. filter goes on top, the sand goes on top. I have to focus this a little bit better again. Okay, it's a little bit dark, I feel. So, yeah. And now we have the other filter goes on top, and we're going to cross it. And yeah, we have to go up a little bit with the intensity. It's very dark, but you're going to notice something. Yeah, everything's much darker, but the really interesting thing is most of you are gonna say, well, it's not so special, but there are a couple of sand grains that actually have rainbow colors. And that's what I'm interested in. Look, yeah. So basically, what happens is that many substances depolarize and they look bright then on a dark background. But sometimes the substances make nice rainbow colors as well. Yeah, like here. And this can tell you something a little bit, could be that then they're crystalline internally. Yeah. Yeah. So that is essentially the thing here. You can see over here, there are these layers visible. Yeah. Many things essentially, I don't know if you put some hair or some cotton fibers between cross polarized filters, they're going to appear bright because the light simply becomes depolarized, and then it appears to be bright. But I think especially nice is if different wavelengths of the light are cancelled out differently, and then you get those rainbow colors. Yeah. So it might help you distinguish maybe some of the characteristics. And you see, not all sand grains do that. Yeah. Like these ones over here, they do, right? Now let's go in a little bit more. You see, it takes already so much light away that it becomes darker and darker. Yeah. Yeah, and if I open it up a little bit by rotating again, then of course I don't see it anymore. But let's try the Kalahari one as well. I don't know about this one here. By the way, this is the first time I'm ever doing this polarized light with this here. Ah, look here. Interesting. You see some sand grains. No, okay, no. Sand grains, some of them allow all of the light to go through. Some, so it's even different parts of the same sand grain allow different amounts of light to go through. Again, slightly those rainbow colors here. And also look a little bit of what I'm doing at the top here. Okay, look how I'm rotating the filter, and how the bottom filter then seems to become darker as it's canceling out the light. Let's move everything a little bit here. Yeah, so this is kind of the thing. I mean, I don't know, theoretically, you'll also do this with plastic. Look, this is the plastic foil for the tweezers. Yeah, and it's a well-known thing that some plastics produce these rainbow colors as well, because the plastic fibers are kind of aligned, and therefore they also polarize the light. Yeah. So you can actually see even internal tensions. Yeah. So that's simply something that Okay, let's try this one over here. Remember this here from before. Unfortunately, I didn't label it, so I don't remember which sand this is. Yeah. Okay. Ah, look, that's actually quite nice. Look. The dark ones, of course, the dark sand grains, of course, don't allow any light to go through at all, so they completely disappear. Yeah. There are plenty of things to play around with. One of the things that I've also tried to do once, I think, is of course you take pictures of this, then you have nice microscopic artwork. Yeah. So, but that is a little bit playing around with some sand. I can highly recommend to expand your observation range a little bit. Of course, observing water samples and so on is a very fun thing, but there are so many other things as well. Yeah, folks, what time is it now? It's 1 hour and 10 minutes already. I'm slowly thinking about quitting today. I do need your help. Okay, here, that's my messy room. I do need your help a little bit, and that is help me please find some topics to talk about. Okay, Stingray is asking, are you using 2 filters? Yes, maybe it's look. You do the following: you put one filter on the bottom, you put the sample over it, okay, and you put the other filter on top of it, and then you rotate the top one, okay. And that's basically what I've done. Yeah, so please, if you have any specific requests or recommendations, please do post them in the comments section below. Yeah, I do receive questions occasionally, and I will answer them normally also in my other channel if they're too technical. But if there's certain things that you want me to look at or so, then please do write comments below. Otherwise, I'm running out of ideas sooner or later. Okay. Yeah. I would like to slowly stop already because otherwise it's becoming a little too long. I hope that I answered all of the relevant questions. It might be interesting to look at various sandpapers. That's an interesting point. However, please be aware that if you have a sandpaper, I don't know if it is always sand that they're using. It could be some kind of a metallic, some other particles as well. Yeah, in that case, it would be interesting indeed. Yeah? The good thing about sandpaper is it's very flat. So it should be easy to observe. But that's actually an interesting one. Why not put sandpaper under the microscope the next time? Okay, I'll take this as one of the requests here. Okay. So have you ever looked at sand samples before? Yes, thanks, Amy. Okay, let's have a look. What about pollen analysis, honey, as a subject? Yes, thank you for that. Pollen analysis is something that can be easily done. I need to wait until springtime again, and I would like to then get some honey directly from maybe from a local beekeeper, because I have already analyzed pollen under the honey under the microscope. You need a centrifuge. I do have a centrifuge, and then it's possible to actually see the pollen grains, but you will need a centrifuge to concentrate it. Okay. Yeah, and there are some greetings again. It's so good to hear you again this Saturday. We'll watch from the beginning later. Okay, thank you very much for the thank you. Okay. And third attempt to comment, thanks YouTube. Sand is amazing. It can hold so many different minerals. Yes. The sand samples today, unfortunately, I was not able to see any forams for minifera, radiolarians, and so on. There are certain regions in the world that are full of these. These are shells of protists. Unfortunately, I was not able to find them here today. Many of the sand samples here were contained a lot of quartz sand, and but there are also other sand samples around that contain more biological material. Okay, yeah. So maybe I'm going to check my other sand samples as well. I'm going to call it quits for today, people. Okay. Hope you liked the Saturday live stream again about microscopy. Yeah. Hope that I was able to motivate you again a little bit, also to try out a few things. And yeah, I would like to then just quickly read the remaining comments here, and otherwise I'm just going to say bye-bye and happy microbe hunting as always, and see you around next time again. All the best. Have a nice week.